In this video, we're going to review sections 12.1 through 12.5, but we haven't covered 12.4 yet, so we will include that as we talk through these sections. So here's a picture. What is it a picture of exactly? What are the vertex points? What are the edges? What are the lateral faces? What are the bases? And given these measurements, what is the volume, surface area, and lateral area of this shape? All right, let's look at these answers. It's called a rectangular prism. It's a prism because it has congruent shapes on the top and the bottom, and all straight lines. The vertex points are just these points, A, B, C, D, E, F, G, H, single capital letters with commas in between them. The edges are segments, so they have two letters with a little segment over the top, A, B, B, C, etc., etc. We got 4 on the top, 4 on the bottom, and 4 that go up and down. So there's 12, top, bottom, up and down. The lateral faces are the ones on the sides, not the top and bottom. And I used 4 letters, for instance, for the front, A, D, H, E, but I really only have to use 3 letters. So any 3 of those 4 would be the right answer. For the bases, now you're talking about the 2 congruent shapes. In this case, I'm going to use the top and bottom for my bases. Somebody could make the argument that the sides are my bases, and this thing is just sideways, and then these would be the lateral ones. But I don't think it really matters here. Pick 2 that are the same size, that are across from each other, and call those the bases. For a prism, the volume equals the area of the base times the height. The area of the rectangle times the height. Length times width times height. The surface area equals all the areas of the sides and the top and the bottom. So I have all these different rectangles. I can take care of all the sides by doing just the perimeter all the way around times the height. That takes care of the right, the left, the front, and the back. It all takes care of it right here. The 2 bases would be the bottom and the top. So there's all the perimeter all the way around times the height, and 2 bases, each which are a rectangle. For the lateral areas, that does not include the top and bottom, only the sides. So I only need that first part. I don't need the top and the bottom. So it's just a portion of the surface area. Notice that volume has cubic units, always, and area, whether it's lateral area or surface area, will have square units, always. Here in our second example, we have another prism. But in this case here, we cannot use the bottom and the top to be our 2 bases. Those are not the same. That's a rectangle. That's a segment. So those cannot be the bases. So which are the 2 shapes that are exactly the same, that are across from each other, parallel to each other? So that would have to be the triangle here and the triangle here. In this case, this is a prism that is lying on its side, and these are the 2 bases. The bases must be congruent to each other. All right, so in this case, the name of the shape is a triangular prism. There's the triangle. There's the other triangle. So the name of the prism gets its name from the shape of the base. And there must be 2 bases that are identical to each other and parallel to each other. The vertex points are just the A, B, C, D, E, F, commas. Edges, segments, 3 on the front, 3 on the back, 3 connecting front to back. So there'll be a total of 9. The lateral faces here are the faces on the sides, so that would be the bottom, the right-hand side, and the left-hand side. Again, I could use 3 letters if I wanted to, and that would be fine. For the bases, they're the 2 triangles. I only have 3 letters for each of those that I can use. There's 2 bases. For every prism, there are 2 bases, parallel and the same size. Volume is the area of the base, so it's the area of the triangle, times how high it goes from the one base to the other base. So the triangle is 1/2 6 times 5. 1/2 length times height times 10, the height of the prism. Now for the lateral area, I only need these 3 rectangles here, which means I need the perimeter times the height. The issue with the perimeter is I don't know how long these 2 sides are. You can see that they have little slash marks, so I know they're the same, but I don't know what they are. I know that's 6 and I know that's 5. But I can see that I have a right triangle right here, so if I know that this is 5 and this little piece is just 3, then I can do my Pythagorean formula to figure out what this side is, which is also the same as this side, and then I will have my perimeter. So I've got a squared, b squared, a squared, b squared equals c squared. That's my side that I'm trying to figure out. Now I know my perimeter is a 6 and a 5.83 and another 5.83. That's my perimeter. And my height is from the front to the back, from one base to the other base, and I can get my answer. Now my surface area is that same exact answer. So surface area is a duplicate of lateral area, but you need to add the bases as well, which means I need to add the area of the triangle twice. 2 times 1/2, 6 times 5. And that'll get me my answer. Again, cubic units on the volume, square units on both of the areas. In this picture, we have a cylinder. It's not a prism, even though it has 2 bases that are congruent and parallel to each other. It's not a prism because it's not all straight lines. We have curvy lines right here. So it's not a prism. It's called a cylinder. We don't talk about vertex points anymore because those are points where straight lines would meet. We don't talk about lateral faces. Lateral faces would be polygons, so they'd be like rectangles or triangles. Not here. The bases here are circles, but we're not going to name them with letters, just circles. Our volume, lateral area, and surface area, we use the same exact formulas as for prism, but the base now is the area of a circle. And the perimeter is the circumference of the circle. That perimeter is the perimeter of the base, which is a circle. So my volume is pi r squared. The radius is half of the distance across. So this is the diameter. So cut that in half, 5. So pi 5 squared times the height of 6. 2 pi r, that's the perimeter, my circumference, 2 pi r, times the height, 60 pi. I'm keeping the pi right in it, so you don't have to multiply it times 3.14. You can if you want. You get something about 185. And for the surface area, I use, again, the exact same pH part that I just got. Use it again, plus 2 areas of the bases, 2 areas of the circles, 2 pi r squared. Add those together. Cubic units, square units, square units. Keep the pi right in it. Okay, this is the part where we get into that last section of chapter 12, which is 12.4. This shape is a pyramid. It comes to a point at the top. It has a base that is a regular hexagon. So it's called a hexagon pyramid, or a hexagonal pyramid if you want to be fancy about it. You name the pyramid by the shape of the base. Hexagon pyramid. Now it has 2 heights actually. It has the straight up and down height, which is h, and that's the height that will be used to find the volume. As well, it has this height that's on the slant, and they call it the slant height, and they use L for that, slant height. That is the height that we will use for the lateral area and the surface area for pyramids, as well as for cones. Height, slant height, and connecting them is the apothem that goes from the center out to the edge. And that's a right triangle, so that's an a squared, b squared, c squared situation there. The 6 is the side length right there. Okay, so for volume, we have 1/3 the area of the regular hexagon, which is 1/2 SAN, that's our old formula for regular polygons, times the height, which is the straight up and down height, which you use for volume. So I plug in my side length, my apothem, my number of sides, and the straight up and down height. For my lateral area, it's 1/2 the perimeter. Now the perimeter is just 6 sixes, that's the perimeter all the way around, times the slant height. That's what I need to use there. And for my complete surface area, I use that same exact number, that's the first part, plus one base now. I just have, there's just one base for a pyramid, so that's 1/2 SAN, and I get my answer. Now if all these numbers had had the unit of inches on them, then the only thing would be that I would need to add all my cubic squared units for being in inches. H for the volume, L slant height for the areas. Just a little explanation as to why these formulas are what they are for lateral area. For a prism, we have rectangles or squares, or in this case a rectangle, so the area of each of this side is 6 times 4, and it uses the straight up and down 4. But the area for this pyramid for this side is 1/2, it's a triangle, 1/2 6 times 4. And as you can see, this triangle is slanted, so we use the 4 that doesn't go straight up and down, but like this. That's for one side, that's just for the area of this one piece. Now if we imagine instead of one side, we go all the way around. Instead of 1/6 times 4, we have 4 of them now. And so that'll be 4 6 times 4. Well, that all the way around, those 4 sixes, that's the perimeter. 4 sixes times the height. And we're over here, we have all 4 all the way around, so it's 4 of this one triangle, 1/2 base times height, 1/2 6 times 4. So 4 of these. And again, 4 sixes is the perimeter, and there's my 1/2, and there's my slant height of 4. So trying to show why this formula makes sense. And if you didn't get this part, it's fine. There's the formula for a prism. There's the formula for a pyramid. In this last example, we have a cone, has a radius of 6, has a slant height of 10, and we are going to find the lateral area, surface area, and volume of this. For the lateral area, it's 1/2 the perimeter of the base, so that's the circumference of this circle, perimeter of the circle, times the slant height. Okay, so when it comes to a point at the top, whether it's a pyramid or a cone, like this is a cone, we will use the slant height for area, L and S. So 1/2 2 pi r times the slant height. 1/2 2 pi r times slant height again, plus the one base, and the base now is the base of the circle, so that's pi r squared. Now for the volume, I need to use the straight up and down height, which I don't know. But I have a right triangle, so definitely if you have the radius, slant height, you can find the straight up and down height. So I do my Pythagorean formula, making sure that my slant height is my longest side. Solve for x, which is the height, straight up and down, 8. My area of the base is the area of the circle, so 1/3 pi r squared times 8. All right, you can probably see this unit is all about formulas, and so we're finding volume, lateral area, and surface area of prisms or cylinders, and of pyramids or cones. P is for perimeter of the base, B is for area of the base, H is straight up and down height, and L is the slant height. Use these formulas, and don't forget your units. Cubic units, square units, square units.